What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at a simple machine learning example. So let's get to it. Now, to increase our level of relatability, to machine learning. So you guys know we have went over quite a few, I would say, articles that kind of build up on the explanation of machine learning. And now, for us to get the highest level of relatability, the best thing we can do is look at an example. So I should mention, right, a very interesting point that I should mention before we actually look at this example is that, you see guys, think back of your school days, right, your high school days. Do you remember your first mathematics class in which you were introduced to drawing a line of best fit across data points that are scattered on a scatter plot? You see guys, that line of best fit required that the number of data points located above the line was equal to the number of data points below the line. So have a look at this visualization here. The line of best fit that we see is the orange line that is running across the data points. Now you see guys, what your mathematics teacher did not tell you at that time was that the actions you are performing during that very moment was a simple form or type of machine learning technique. It's called linear regression. So logically speaking, from high school days, machine learning has been applied in mathematics to some extent, but the teacher did not know, or they did not just tell y'all or tell us that, we are working with machine learning concepts. So let's move on to our example, keeping in mind the teachings that we learned in school. For number one, we have the data preparation phase. Let's say we have a simple data set that comprises two features, crime rate and house price. Our data is in good condition and needs no further actions to be taken for preparation. We would like to predict the value of house price, therefore making it our target vector and dependent variable. As we know, the dependent variable will be found on the y-axis. So we see a table, guys. This is the data we have, crime rate and house price. Now, we will use the remaining features, namely crime rate, to make the predictions, therefore making it our features matrix and independent variable, which will place it along the x-axis. To gain further insight into our data, let us plot a visualization of the data as seen below. And look at this image, guys. We see a scatter plot here, effect of crime rate on house prices. Crime rate is measured in percentage, and we see house price is in rands. So rands is the currency that is used in South Africa, if you did not know that. So as we can see from the visualization itself, there's a scatter plot showing us the position of the data points relative to each other. Looking at the graph and the data points, one can anticipate that there is a direct relationship between crime rate and house price. We know this because as x increases, so does y. So number two, the algorithm selection phase. In our particular problem, we wish to predict house prices. The house price feature takes the form of numerical data, that is quantitative values. Now go up a bit, guys, and look at the data table, focusing on the house price R column. Quantitative or numerical data will tell us the amount, quantity, or measurement of something. So if we slide up a bit, guys, we see house price is measured in a quantitative value. It's a numerical value. It is telling us a quantity. In this case, the quantity is a measurement of the price of the house itself. So now notice these values are continuous. There's no fixed or predefined range within which the values can belong. That is why they are called continuous. Now, to predict values of this nature, we require a method or algorithm that will be able to learn the trend in the dataset once off and allow us to use the model for making future predictions pertaining to house prices. The method that we will select, or algorithm that we will select, will be the straight line graph or linear regression. It has the following formula: y is equals to mx plus c. Let us analyze this formula. Number 3, the model compilation phase. You see guys, now that we have effectively selected the algorithm to utilize, we may proceed to expose the algorithm to the data in order to obtain a successful, powerful model. Okay, when an algorithm is applied to data, the process of forming the model involves mathematics and statistics. The model needs to be carefully choosing and selecting the best coefficients to make use of in the formula itself. One must understand that the model's digital compilation and selection of coefficients that occurs during the machine learning process tends to happen in back-end processes that cannot be seen by the human being. Now this is an important statement, guys. Why? Because you see, as we will encounter our journey with machine learning using Python in future videos, we will see that none of the back-end processes and the footing, processes are shown on screen in the front end to the user. Everything happens back-end internally, by the processor itself. So, however, when brought forward into the light, each of these intrinsic processes can be expressed mathematically in the form of formulae and equations, and one is able to see exactly how the model has reached those conclusions. Now, this is important. We have spoken about this concept multiple times in the past few videos about how every machine learning concept and process and technique can be expressed using pen and paper mathematically. We don't see this because the computer, as I said, does everything for us. Everything is done for us internally by the CPU of the device. So y is equals to mx plus c, where y is the value for the y variable, in our case house price, x is the value for the x variable, in our case crime rate, m is the gradient of the graph, and c is the y value at the point the gradient intercepts the y-axis. So basically, c is representing the y-intercept. Okay, upon doing the mathematics manually, one will find m is equals to y2 minus y1 all over x2 minus x1. Two data points needs to be substituted into the respective placeholders. So m is, what you see here is the standard formula for gradient. To calculate the value of c, we'll make it the subject of the formula by substituting a third data point into the equation and, performing the calculation. So you guys see, we actually calculate the respective components of the equation itself. So to calculate m, we have the data points 10 and 10,000, 20 and 20,000, and we have, done a substitution. So now we have y is equals to 1000x plus c. Next, to calculate the value of the intercept c, essentially what we did is use the data point 60 and 60,000, and that gave us 60,000 is equals to 1000 into 60 plus c. C evaluated to 0. So the final calculation of model is going to be y is equals to 1000x. Last but not least, we see number 4, the evaluation / prediction stage. Now that we have successfully compiled a model, we may proceed to evaluate its predictive power and use it to make predictions for future scenarios. Suppose we have a community in which the crime rate is 70%. We wish to know the approximate price of a house based on this figure. With machine learning, making a future prediction becomes simple. We simply make use of the model. Predicting the house price for a 70% crime rate. We have y is equals to 1000x, house price is equals to 1000 into 70, and that evaluates to a value of 70,000 rand. Now, you guys should realize, right, that, a fact is that in this example, I've used a very simple example scenario for us. One is able to see that the model's prediction is 100% accurate if the data follows a continuous trend, as we've seen in the table and scatter plot. We may confidently say that a crime rate of 70% will cause a house price to be 70,000 Rand. Hence, we can assume that the model has achieved 100% accuracy in its predictions. Now, I mentioned this before. The reason as to why I call this stage evaluation/prediction is because I believe it is good practice to evaluate model performance before attempting to make a prediction. This gives us insight into our model's margin of error, thereby notifying us of up to what level or degree our model could be incorrect in its prediction. So guys, I hope you guys, have a good understanding of machine learning. The past few videos that we've covered was really just a, introduction to machine learning kind of crash course. I have a full machine learning tutorial planned for the channel, and I hope to start recording that soon. But over the next few videos, we are going to look at some of the content that is still on the website itself. So in the next few videos, we will cover, so you guys know, right? Data science is a trending topic and field in the modern day. And what I'd like to do is, I have a few articles up on the website, and it covers some very important and interesting data science interview questions. So what I'd like to do is, create video content on those articles themselves. So I think there's about 74 or 75, I'm not too sure, but I'll try to condense those 75 or so questions and answers in as little videos as I can. So maybe 15-minute videos or so, but we'll see how that goes. So with that, we have successfully reached the end of this video. Thanks so much for watching, guys. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.